Okay, so let's talk airplane safety for a sec.
Okay.
You know how much goes into making sure a plane full of people can fly at 30,000 feet and nobody even thinks twice.
Yeah.
I mean, it's mind-blowing how much analysis and testing and paperwork there has to be.
Right.
And, there's this buzz now about whether AI, the new AI, like those large language models, the LLMs,
Yeah.
could they actually like step in and make parts of that whole safety process faster or even better?
It does sound a little bit like magic at first, doesn't it?
Yeah, like a total game changer, right?
Well, that's exactly what we're going to kind of dig into today.
Yeah.
You sent me this really interesting report from NASA, a technical memorandum.
Yeah.
It's by Dr. Mallory Graydon and Dr. Sarah Lehman, and they really get into this question of how could we use LLMs to actually create or evaluate
Right.
what are called assurance arguments for these really critical systems.
Okay, so assurance arguments, that sounds
Yeah.
pretty technical.
Yeah.
For those of us who maybe aren't, safety engineers by trade.
Mm-hmm.
Right. Can we just break down, like, what are we even talking about here?
So you can kind of think of an assurance argument as a really carefully structured logical argument,
Okay.
and it's meant to demonstrate with like clear evidence and reasoning that a system is safe.
Okay.
In our case, like the airplane.
Right.
It's safe and dependable. So it's that whole justification for why we should feel confident that it's safe to fly.
So this is essential when we're talking about getting like approval.
Yeah.
From the FAA or whoever.
So this is fundamental to being able to get something certified.
Right. So this is like the bedrock of like
Yeah.
safety approval, right? So
Absolutely.
no small potatoes. And this NASA paper
Yeah.
really is looking at like, could LLMs come in and just like totally change this whole thing?
Yeah.
What's the core message? Like, what do you think the listener should really take away from this?
I think the main takeaway is that there's a lot of excitement about the potential for LLMs to be used in this field. But the NASA report is also like a really important reality check.
Okay.
They highlight some really big challenges and some really important questions that don't have really great answers yet.
Okay. So this is not just plug and play.
It's not just plug and play. No, it's not.
Yeah.
It's there are definitely benefits, but there are some serious challenges we need to address before we'd be ready to trust LLMs with this kind of responsibility.
Okay. So let's get specific.
Yeah.
What are some ways that researchers are suggesting that we could use these LLMs in the world of assurance arguments?
So the NASA report kind of grouped the ideas into three main categories.
Okay.
The first one is actually having LLMs generate parts of or even entire arguments.
Okay.
So this could be like drafting the claims.
Yeah, okay.
So like what are the things we're trying to say are true?
Yeah.
The premises, the reasons why we think they're true, or even constructing complete arguments
Okay.
in a very structured way, like using something called goal structuring notation or GSN.
That sounds really ambitious. Can you give us some examples?
Yeah, so imagine you have an autonomous driving system.
Okay.
So some researchers are looking at whether LLMs could be used to generate claims and subclaims that change
Okay.
with the situation that the car is encountering.
Okay.
So you've got all these different things happening on the road.
Yeah.
You need to adjust the argument for safety
Yeah.
as the situation is changing. So that's one example.
Okay.
And another one is in aviation, maybe LLMs could be used to pull out the safety claims from like those giant regulations that the FAA puts out,
Yeah.
like 14 CFR Part 2.5.
Yeah. No kidding. It's a beast.
Yeah. So it's like, can they pull out the really key stuff for us automatically?
So it's about automating that like first
Yeah.
really labor-intensive part.
Yeah, just get the first draft or identify those key pieces.
Okay. Fascinating. What about the second area?
So the second area is about generating potential defeaters for an argument.
Okay.
So a defeater is like a valid challenge or counterargument that might weaken your main safety case.
Right. Okay. So like if your argument is this sensor is super reliable, a defeater might be like, well, actually, in these conditions, it's known to fail.
Yeah, like there's this one little corner case where that sensor actually doesn't work.
Okay.
And that's really important to know, right?
That's interesting. So it's like being your own devil's advocate. Like,
Yeah.
let me try and poke holes in this.
Yeah. And the report actually says that some people think this is like less risky
Okay.
than actually having the LLM write the whole argument.
Okay.
Like maybe it's easier to review a list of possible problems
Right.
that the LLM came up with and see if any of them are real problems
Okay.
than it is to check every single detail of a giant argument that the LLM wrote.
Right. Like, where do you even begin with that?
Yeah, exactly. So this is kind of seen as a possible, like, first step.
Okay. A lower risk way to start?
A lower risk way to start, yeah.
Okay. What's the third one?
So the third category is using LLMs to take these arguments that are written in normal language and turn them into a format that a computer can understand.
Okay.
Like a really formal, precise language.
So formalizing it.
Yeah, formalizing it.
Okay.
So this means, like, turning the claims and the evidence into something that a computer can easily process and check.
Okay.
And there are different ways to do this, like using logic formulas or special languages for hardware.
Okay.
Or even logic programming languages.
Can you give me an example of that?
Yeah, so let's say you have a rule in software development that says no one person can write and approve a piece of code.
Right, like you need a second set of eyes.
Yeah, exactly. You need that review.
Yeah.
So an LLM could take that rule and turn it into a logical statement.
Okay.
That a computer program can then use to check if anyone's breaking the rule.
Gotcha.
Or, like, another idea is formalizing those safety things so you can test them in a simulation.
Oh, interesting.
On a computer.
Okay.
And get some, like, computational evidence to support the argument.
So it seems like the big picture here is, like, we want to make this whole assurance process faster and less prone to, like, just human mistakes.
That's a big part of it, yeah.
Yeah.
Researchers have a few main motivations.
Okay.
One is this whole problem of human fallibility.
Okay.
We make mistakes, right?
Of course.
And building and reviewing these really detailed safety arguments is a really hard mental task.
Yeah, no kidding.
It's very demanding. And we can miss things, we can be biased, we can make simple errors.
Right.
The hope is that maybe automation can help with some of these risks.
But is there a counter argument to that?
There is, actually. And the NASA report points this out.
Okay.
Automating things doesn't make human error go away.
Right.
It just shifts where those errors might happen.
Oh, interesting.
So instead of making a mistake in writing the argument,
right,
we might make a mistake in how we're telling the LLM what to do.
Right, or how we interpret what it gives back to us.
Exactly, or misinterpreting its output. So it's a trade-off. It's not a perfect solution.
Okay, so more like shifting the risk.
Yeah, shifting the risk, yeah.
Yeah. Okay, what's another big reason for exploring LLMs here?
So another big one is cost reduction.
Okay.
Creating and reviewing these arguments takes a lot of time.
Yeah.
A lot of really skilled work.
Yeah.
And so the hope is that LLMs could automate some of this.
Right.
And save money.
Right, for the companies and for the regulators, too.
For the companies and the regulators, yeah.
Right.
Less work for everybody, potentially.
Has anybody actually, like, tried to calculate how much money we're talking about here?
So this is interesting. The NASA report actually says that there aren't a lot of studies.
Oh, really?
That have really tried to measure those cost savings.
Ah.
So it's a compelling argument in theory.
Yeah.
But we need some hard data to back it up.
Right.
We need to see some numbers.
Okay.
Before we can say for sure.
The report also mentions this idea of using LLMs for dynamic risk monitoring.
Yeah.
Is that something that we should get into here?
It's mentioned as like a less common motivation. So the idea is LLMs could be used to constantly monitor and assess risks in systems that are already working.
So like after it's already deployed and everything?
Yeah, like keeping an eye on things in real time.
Right.
But the authors of the report say they're really focusing on using LLM and creating and evaluating the arguments you need to get certified in the first place.
Gotcha. So for this conversation, we're going to stick to that initial.
Yeah, we'll stick to the core argument for getting approval.
So we know how people want to use LLMs. We know why.
Yeah.
But the really big question is, how do we know if they're any good at this?
Right.
How do we even measure that? How effective are they?
Yeah, efficacy.
Yeah.
How good are they at doing what we want them to do?
Right.
It's a really key question. And the NASA report spends a lot of time on this.
Okay.
One of the things that researchers have done is to basically quiz the LLMs on how well they understand the way we write arguments.
Okay.
Like those special notations and structures like GSN or eliminative argumentation.
So like giving the chatbot a test.
You kind of like a test.
Like safety case 101.
Yeah, exactly. So for example, there was a study where experts in eliminative argumentation gave GPT-4 Turbo a 22-question test on the basic principles and structure.
And it got an A.
It got an A.
Yeah, it did really well.
So does that mean we're good to go?
Well, hold on.
Okay.
This is where the report makes a really important point.
Okay.
Just because an LLM knows the rules and can pass a test doesn't mean it can actually use that knowledge to build real safety cases.
Oh, interesting.
It's like knowing all the grammar rules of a language, but not being able to actually have a conversation fluently.
Okay.
You know the pieces, but you can't put them together in a meaningful way.
So knowing the rules of the game doesn't mean you can play the game.
Exactly.
Okay, so if just quizzing them isn't enough, how else are researchers trying to figure out how good they are at this? So another thing they're doing is something called replication checks.
Okay.
So they take real safety work that humans did,
Okay.
like a set of defeaters or part of an argument or even a whole safety case.
Okay.
And they ask the LLM to generate something similar.
Gotcha.
And then they compare what the LLM made to what the human made.
Okay.
To see how well it matches.
So that's more like a head-to-head.
Yeah, it's a more direct comparison.
Okay, so what are the results of these replication checks showing us?
So the results are kind of all over the place, but there's a big problem with a lot of these studies.
What's that?
The human work that they're comparing the LLM's work to might have been part of the data that the LLM was trained on in the first place.
Okay.
So it's possible that the LLM is just repeating what it already saw.
So it's not really generating anything new?
Yeah, it's not really showing us that it can come up with new ideas.
Right, it's just like regurgitating stuff.
Yeah, exactly, like a student copying from an answer key.
Yeah, and saying, hey, look, I did the work.
Exactly.
Right.
So it's a big problem for these studies.
Yeah, that really undermines the whole thing.
It does.
Yeah.
Okay, so
the report gives a specific example of this from a study by Gohar and his colleagues.
Okay.
They asked an LLM to come up with defeaters for safety arguments about the Large Hadron Collider and a small drone.
Okay.
But it's hard to judge how good a defeater is automatically.
Right.
So they had human experts look at the LLM's suggestions and decide if they were a complete match, a partial match, or no match at all.
Gotcha. So what did they find?
So the LLM did find a good number of defeaters, but it missed some important ones that really needed deep knowledge about the system that wasn't spelled out in the prompt.
Right. So it didn't have all the information it needed.
Yeah. And another interesting thing was that how they asked the LLM the question really affected how good its answers were. And sometimes giving it more information didn't make things better.
That's surprising. Yeah, you'd think more information is always good.
Right. More data, more better.
Right, more is better. But it seems like that's not always true with these LLMs.
Oh,
so we're still learning how to best work with them.
Okay.
And the report also mentioned some other challenges in figuring out how good LLMs are.
Yeah.
Like sometimes they use those argument notations inconsistently.
Okay.
Or they come up with the wrong number of defeaters.
Right.
And it's hard to judge the quality of an argument automatically.
Yeah, because it's so subjective, right?
It is. Yeah, it's very subjective. So it's not a simple problem.
So basically, the ways that we have now to check how good they are have some pretty big limitations.
They do, yeah.
Okay.
Like, we're relying on information they might have already memorized.
Right.
The studies often use simple examples.
Okay.
And we don't really know everything they were trained on.
Right. So it's hard to draw big conclusions.
It's hard to know for sure
how
good they'd be in the real world.
So besides the whole problem of measuring how good they are? Yeah.
Does the report point out any downsides?
Yes.
To actually using them?
Yes, it does.
Okay.
One big one is the risk that they might just make things up.
Okay.
Especially when dealing with complex technical stuff and specialized knowledge.
Yeah.
Because LLMs learn patterns in language. They don't really understand what they're saying.
So they don't know if it's actually true.
Exactly.
Right.
They can sound very convincing.
Right.
But what they're saying might be completely wrong.
Okay, so even if they write an argument, a human expert still has to check every detail.
Absolutely.
Okay.
You cannot just trust it.
Right.
You need that human oversight to make sure it's not making stuff up.
So what you're saying is that an LLM could potentially create an argument that sounds really good on the surface.
Yeah.
But is based on totally faulty information.
Exactly. And the report also worries that LLMs might misunderstand little details in the way we argue or in specific rules and regulations.
And those are things that humans are still much better at.
Okay, so given all these problems and risks, what do the researchers think we need to do before we can even think about using LLMs in this area?
Well, one big thing is that we need clear standards.
Okay.
for what counts as good enough.
Right.
Like, what's the minimum level of performance?
Some benchmarks.
Yeah, benchmarks, exactly. And we don't have those yet.
Okay.
The researchers suggest a bunch of things for future work.
Okay.
Like trying out different LLMs and different ways of prompting them.
Okay.
And building LLMs specifically for safety.
Okay.
And doing more experiments with more complex argument patterns.
Okay.
And really focusing on those human-in-the-loop approaches.
Okay.
Where humans and LLMs are working together really closely.
So it seems like this idea of humans and LLMs collaborating is really important, and that maybe fully automated solutions just aren't realistic.
That's a good observation, and I think that really is a key theme that emerges.
Yeah.
And now the NASA report also takes a step back and looks at how LLMs are actually trained.
Okay.
And how they work.
Okay.
And how that connects to these worries about how good they are at making safety arguments.
Okay, so just as a refresher, can you remind us about that LLM training process?
Sure.
How do they learn?
So the typical way involves two main steps.
Okay.
First, you train the LLM on a massive amount of text data.
Okay.
Like just tons of stuff from the internet.
Books, articles, websites.
All kinds of stuff.
Okay.
And in this first step, the model is just learning the relationships between words and phrases.
Right. Patterns in language?
Yeah, patterns in language.
Okay.
And then the second step is called reinforcement learning from human feedback.
Okay.
Or RLHF.
Okay. RLHF.
RLHF.
Okay.
And this is where humans actually look at what the model is producing and give feedback to make it better.
Gotcha.
More aligned with what we want.
Okay, so they're kind of guided by human feedback.
Yeah.
Okay, and then when an LLM is actually running, like when we're using it,
right,
what's happening?
So it takes your question or your prompt, breaks it down into little pieces called tokens.
Okay.
And then based on those patterns, it learned during training.
Okay.
It predicts what the next token should be.
Okay.
And it just keeps doing that until it's generated a whole response.
And you said it predicts the next token, so is there some randomness to that?
Yeah, that's a really important point.
Okay.
It's not deterministic.
Okay.
It's making probabilistic choices.
So even if you ask the same question twice, you might get a different answer.
You might get a slightly different answer.
Okay.
And this can be a problem for safety arguments.
Right, because you want to be able to replicate things.
Exactly. You need consistency.
Right.
And this makes it hard to compare results from different studies, too.
Right, if everybody's getting slightly different outputs.
Yeah, okay. And the report brings up this idea that LLM outputs are often
BS.
BS.
Yeah. Okay, for people who don't know, what does that even mean?
So this is a really important concept.
Okay.
It's from a philosopher named Harry Frankfurt.
Okay.
And he defines bullshit as speech that's made without caring if it's true or false.
Okay.
And the argument is that LLMs are trained to match patterns.
Right.
They don't actually understand truth.
So they don't know if they're lying or telling the truth?
Exactly.
They're just spitting out words?
They're just generating text.
Yeah, okay.
That sounds plausible.
But it could be totally made up.
Exactly.
Okay. Can you give me some examples of that from the report?
Yeah, so one example is an LLM that gave totally wrong information about towns in Pennsylvania.
Okay.
Like distances and highway connections were completely messed up.
It sounded like it knew what it was talking about.
Yeah, it sounded totally believable.
Okay, but it was just wrong.
It was just plain wrong.
Okay, what else?
Another one is an LLM that made up scientific information about a medical condition.
Okay.
It even invented references to research papers that didn't exist.
So it's making stuff up, and it's even like giving fake citations.
Yeah, it's really worrying.
Yeah.
Because it all sounds so plausible.
Right.
And if you don't know the field really well, you might not catch it.
So this BS problem is a really big deal.
It's a huge deal.
When we're talking about safety critical stuff.
Yeah.
Because if there's a false premise in your safety argument, the consequences could be disastrous.
Exactly.
So human review is absolutely essential.
It's non-negotiable.
Right.
You can't just take the LLM's word for it.
You've got to double check everything.
You have to double check everything, yeah.
And the report also talks about problems with LLM-generated code. Yeah. Which is another area where people are really excited about using LLMs.
Right. People are trying to use them to write code.
Right.
And studies have shown that the code that LLMs generate can have all kinds of problems.
Okay.
From basic errors that make the code crash to more subtle logic problems that could make it do unexpected things.
Okay.
Or even create security vulnerabilities.
And this isn't just limited to code, right?
No, it's not.
Like we've seen examples of LLMs making stuff up in other fields too.
Yeah, like legal documents with fake citations.
Right.
Academic papers with made-up references.
Yeah.
Seems like it's easy to get fooled.
So just because something sounds right doesn't mean it is.
Exactly. And even experts can miss these mistakes.
Right.
So it's a real challenge.
So this brings us back to that whole issue of, like, can we trust LLMs to do this?
Yeah.
And the report argues that quizzing them on their knowledge isn't enough.
It's not enough, no.
Because it only shows that they can understand the concepts.
Yeah.
Not that they can actually apply them in the real world.
In complex situations, yeah.
Right.
And the report uses a couple of interesting analogies here.
Okay.
One is that famous painting by Magritte.
Okay.
This is not a pipe.
Yeah.
So it's a picture of a pipe, but it's not actually a pipe, right? And the other one is that Buddhist parable about the finger pointing at the moon.
Okay.
So the finger's pointing to the moon, but it's not the moon itself.
Right.
And the point of these analogies is that knowing the rules or seeing examples doesn't guarantee that you can actually do the thing in a real situation.
Okay, so we're really talking about the difference between, like, book smarts and street smarts.
Yeah, exactly.
Okay, so given all this, like, what's the point of even trying to automate this whole safety case thing?
Right.
What are we hoping to achieve?
So the report looked at a few different perspectives on what a safety case is for.
Okay.
Some people see it as a way to tell the story of a system's safety.
Okay.
In a clear and convincing way.
Right, so stakeholders understand why it's safe.
Exactly. Okay. Others see it as a direct result of the risk assessment process.
Oh, okay.
Like it shows how you're managing the hazards.
Okay.
Another perspective is that the process of building a safety argument makes the development team think more deeply about safety. And finally, some see it as the main thing that regulators look at.
Right, to make sure you're following the rules.
Exactly.
Okay, and the report seems to focus on using LLMs for, like, new systems that are being developed.
Yeah, greenfield development.
Right, and also for reassessing existing systems that are already out there.
And it mentions operational assurance cases.
Yeah.
Which are more about, like, ongoing safety.
Yeah, like real-time safety.
Right.
But that's not the main focus here.
Okay, so for this conversation, we're sticking to those first two.
Yeah, we'll stick to the core arguments.
Okay, and the report breaks down the process of creating and assessing these arguments into 5 main parts.
Right.
So first you have to understand the system design and do the safety assessment.
Yeah, like the initial analysis of the system.
Right. Then you have to structure the argument itself.
Yeah, how do you organize the argument?
Okay. Then you have to choose the evidence to support your claims.
Yeah, what data are you using?
Okay, and then you write out the reasoning and conclusions. Yeah, like connecting the dots.
Right, and finally you assess the whole argument.
Yeah, is it good enough?
Okay, and for each of these stages, the report asks specific questions about the impact of LLMs.
Yeah, like what would happen if we used LLMs here?
Right. Can we go through a few of those key questions?
Sure.
So starting with system design and safety assessment.
Yeah.
What's the big question there?
So the question is, if we automate the process of building the safety argument, will that lead to less rigorous design thinking?
Oh, interesting.
Or less comprehensive safety analysis?
Right, because the humans are less involved.
Yeah, because when you're writing out the argument yourself, you really have to think through every detail.
Right.
And if the LLM is doing some of that work for you, you might not be as careful.
Okay, so what about structuring the argument?
So here the concern is, will arguments that are written by LLMs or heavily influenced by LLMs be as clear and understandable and persuasive to the humans who have to review them?
Right, because ultimately a human has to look at it and say, yeah, this makes sense.
Exactly. Okay. And if it's not clear or if it's hard to follow, that's a problem.
What about choosing the evidence?
So this raises a bunch of questions.
Okay.
Will LLMs be able to pick the right evidence for the specific system and the specific claim?
Okay.
Will they be able to tell if the evidence is weak or not really relevant?
Okay.
Will they know if new information contradicts old evidence?
Interesting.
And could they maybe help us find better evidence?
Okay, so there are like pros and cons there.
Yeah, it's not a simple answer.
What about the actual reasoning within the arguments?
So here, the question is, will the LLM's reasoning make sense to a human?
Okay.
Will the steps in the argument be logical and clear?
Okay.
Will it be consistent with what we know about science and engineering?
Okay.
And will the level of detail be appropriate?
Right.
And can we catch mistakes in the LLM's reasoning?
Right.
So a lot to consider there.
And finally, what about assessing the whole argument once it's done? Like, how do we know if it's any good?
So the main question is, will automated assessment be as good as human assessment?
Okay.
Can we trust a computer program to catch all the problems
Right.
that a human expert would catch?
Okay.
Like logical fallacies or missing information.
And the report also specifically asks about the cost of all this.
Yeah, question 14 gets right to the point.
Okay.
Will using LLMs actually save money
Okay.
compared to doing everything manually?
And that was one of the big arguments for using LLMs in the first place, right?
It was, yeah.
Like saving time and money.
Yeah. And the report reminds us that the thinking part of building and assessing arguments
Right.
is really hard to automate.
Right.
And if we rely too much on LLMs and they make mistakes,
Yeah.
we might end up spending more time and money fixing those mistakes.
Right, so it could actually backfire.
It could, yeah.
So it seems like efficacy, how good LLMs are at this,
Yeah.
is a really complicated question.